Black holes' deadly secret. Why nothing survives intact. Hello, cosmic explorers, and welcome back to Cosmic Enigma. Today, we're diving into one of the universe's most captivating and misunderstood phenomena, black holes. Have you ever imagined what it would be like to fall into a black hole? Popular culture often depicts a mysterious, perhaps even beautiful journey, a quick disappearance, maybe to another dimension, with the object remaining completely intact. However, this widespread idea is fundamentally and terrifyingly wrong. For decades, movies and science fiction have painted a picture of black holes as cosmic vacuum cleaners or gentle portals. The scientific truth, however, is far more brutal and infinitely more fascinating. When anything, be it a star, a planet, or even an unfortunate astronaut, gets too close to a black hole, it doesn't just vanish. Instead, it undergoes a process so violent that it has its own chilling name, spaghettification. So what exactly is spaghettification? Imagine falling feet first towards a black hole. The gravitational pull on your feet being closer to the black hole would be tremendously stronger than the pull on your head. This isn't a slight difference, it's an extreme gravitational gradient, also known as a tidal force. This immense difference in pull literally stretches you vertically, elongating you like a piece of spaghetti being pulled from both ends. But the process doesn't stop there. Simultaneously, the black hole's gravity pulls inwards from your sides, compressing you horizontally. The combined result is that you are not just stretched, but also squeezed, transforming into a long, thin, noodle-like strand. Ultimately, the very atomic bonds holding your body together, the forces that define your structure, simply cannot withstand these unimaginable stresses. You would be torn apart, atom by atom, into your smallest subatomic components. There is no intact survival in this scenario. As the spaghettified matter falls deeper, it encounters two critical features of a black hole: the event horizon and the singularity. The event horizon is often referred to as the point of no return. It is not a solid surface, but an invisible boundary where the escape velocity, the speed needed to break free from the black hole's gravity, exceeds the speed of light. Once anything crosses this line, be it matter or light, it is irrevocably trapped, destined to fall further inward. Beyond the event horizon, everything is drawn towards the singularity. This is the black hole's true center, an unimaginably tiny point where all its immense mass is concentrated. At the singularity, density becomes essentially infinite, and the known laws of physics, as currently understood, break down. The torn-apart remains of any object are ultimately squeezed into this infinitely dense point. A fascinating twist is that the experience of spaghettification depends on the black hole's size. For smaller, stellar mass black holes, the tidal forces are so extreme that an object would be ripped apart before it even reaches the event horizon. However, for supermassive black holes, like the one at the center of our galaxy, the event horizon is so vast that the gravitational gradient is less steep at the horizon itself. An object might actually cross it without immediate spaghettification. Nevertheless, once inside, the journey to the singularity is inevitable, and spaghettification will still occur, just deeper within the black hole's gravitational well. It's important to clarify some common misconceptions about black holes. They are not cosmic vacuum cleaners that indiscriminately suck up everything in their path. From a safe distance, a black hole's gravitational pull is precisely the same as any other object of identical mass. For instance, if our sun were to instantaneously transform into a black hole, Earth would not be pulled into it. Our planet would continue its orbit largely unaffected, though it would become significantly colder. Furthermore, black holes are not wormholes, shortcuts between different points in space, or portals to other dimensions or universes. These concepts are purely products of science fiction. Instead, a black hole is an extreme concentration of matter packed into an incredibly tiny volume. Their existence is a direct consequence of Albert Einstein's theory of general relativity, which posits that gravity is not merely a force, but a manifestation of the curvature of space-time caused by the presence of mass and energy. When a massive star exhausts its nuclear fuel and collapses under its own immense gravity, its core becomes so dense that it warps the fabric of space-time to an extreme degree, creating a region from which nothing can escape. The persistence of the notion that objects remain intact when encountering a black hole is largely attributable to pervasive portrayals in popular culture. Fictional narratives frequently depict black holes as benign portals or simple disappearance points, which diverge significantly from the violent physical processes dictated by astrophysical principles. It's often easier to imagine a quick, clean disappearance than the horrifying reality of being stretched and torn apart. However, the scientific truth is far more awe-inspiring. Black holes are not just mysterious voids. They are extreme laboratories of physics, where gravity's power is so immense, it literally warps space, time, and the very fabric of matter. They challenge our intuition and push the boundaries of our understanding. Scientists study them indirectly through their effects on surrounding matter, such as observing the behavior of nearby stars, gravitational waves, and gravitational lensing. In conclusion, the widely held belief that objects entering a black hole remain intact is a fundamental misconception. Scientific understanding unequivocally demonstrates that nothing survives an encounter with a black hole in its original form. Instead, objects undergo a catastrophic process known as spaghettification, where they are torn apart into their smallest subatomic components by extreme tidal forces, leading them inevitably towards the singularity. This brutal end is a powerful testament to the universe's incredible, sometimes terrifying power.